Hello students, welcome to Academic Aura. Today we begin with practice set 1.4 of the chapter Similarity. Now in this practice set, we will refer to this theorem, the theorem of areas of similar triangles. Okay. Now see here, when you have two triangles that are similar, when two triangles are similar, A, B, C is similar. Suppose if I say triangle ABC is similar to triangle PQR. Okay, when these two triangles are similar, the ratio of the areas of those two triangles, that means the ratio of the areas of those two triangles, that means area of triangle ABC upon area of triangle PQR is equal to the ratio of the squares of their corresponding sides. That means ratio of their squares of their, so the corresponding sides. If I take this side AB upon PQ, these are the corresponding sides. They have said is equal to the ratio of the squares of their corresponding sides. Suppose if I take AB upon PQ, here you can take AC upon PR square, AC square upon PR square. Okay, we took first AB upon PQ square, AC upon PR square, and then you can take BC square upon QR square. Okay, so the ratio, when two triangles are similar, the ratio of their areas, of those two triangles is equal to the ratio of the squares of their corresponding sides. Okay, so the next practice set is based on this theorem. So see the first sum. The ratio of corresponding sides of similar triangles is 3:5. Okay, ratio of corresponding sides of two similar triangles is 3:5. Find the ratio of their areas. We have to find the ratio of the areas. Now the corresponding sides, their ratio is given 3:5. So what we will say, solution, we will say that let the ratio of the corresponding sides of two similar triangles, let the ratio of the corresponding sides of two similar triangles be S1 and S2. Okay, the ratio of the corresponding sides of two similar triangles be S1 and S2. Now we will say the areas, let their areas be A1 and A2. Let their areas be A1 and A2. Okay, their sides will be, the corresponding sides will be S1 and S2, areas will be A1 and A2. Now what is given? The sides is given, the ratio of their sides is given, that means 3:5. That means S1:S2 is equal to 3:5. The ratio of the corresponding sides is given. Okay, now we have to find the ratio of the areas. So ratio of the areas, we know that the ratio of the area of two triangles, that is A1 upon A2, is equal to the square of their corresponding sides, is equal to the square. That means S1 upon S2 is equal to the area of, ratio of the area of two triangles is equal to the square of the areas, the ratio of the areas of two triangles, that is you have to square over here. Okay, so this is by theorem of areas of similar triangles. Okay, now A1 and A2, that is the ratio of the areas of two triangles, we don't know, so we will write it as it is. But we know S1 and S2. S1 is to S2 is 3:5. That means 3 square and 5 square. Okay, 3 square. S1 is 3 and S2 is 5. That means 3 square and 5 square. Now when we square it, A1 upon A2 is equal to 3 square will be 3 3s are 9 and 5 5s are 25. Okay. So what was asked? Find the ratio of their areas. So ratio of the areas of two triangles we got 9 is to 25. So we can write answer. Find the ratio of their areas. The ratio of their areas is 9 is to 25. Okay. So this is your first sum. Now see the second sum. Here they have told you that triangle ABC is similar to triangle PQR. Okay. These two triangles are similar and AB is to PQ is 2 is to 3. AB is to PQ. That means AB we have taken these two corresponding sides AB and PQ. So what will come here? AB square upon PQ square. AB square upon PQ square. Now AB is to PQ is 2 is to 3. That means AB square upon PQ square is AB upon PQ will be 2 is to 3. So when you square this, you will get 2 2s are 4 and 3 3s are 9. Now see the third one. If triangle ABC is similar to triangle PQR, okay, ABC is similar to triangle PQR, area of triangle ABC is 80 and area of triangle PQR is 125. Okay. Now then fill in the blanks. Now only this is given. Suppose see, area of triangle ABC is similar to triangle area of triangle PQR. So here we will write PQR. So here you can write PQR because these two triangles are similar. Okay. Now area of triangle ABC is 80. ABC is 80 and PQR is 125. Now what we will do is, now see for the working, we know that areas, the ratio of the areas of two triangles, write down area of triangle ABC upon area of triangle PQR is equal to the ratio of the squares of their corresponding sides. Now which two corresponding sides we will take? AB and PQ. That means we will take AB square and PQ square is equal to AB square upon PQ square. This is by the theorem of areas of similar triangles. Okay. Now see this. Suppose the area of triangle ABC is 80 and PQR is 125. So in place of ABC we will use 80 here and in place of PQR, area of triangle PQR is 125 is equal to AB square upon PQ square as it is. Now what we will do is we will divide these numbers. Okay, we can reduce it to the lowest form by 5. Suppose if you take 5 2s are 10, carry 2, 5 5s are 25, 5 1s are 5, 5 6s are 30. So what we get here is AB square upon PQ square is equal to 16 upon 25. So here we get AB square upon PQ square is equal to, see when we reduce it we get 16 upon 25. Okay. Now what we will do when we take out the square root, when we take the square root the square will get cancelled. Square root of 16 will be 4 and square root of 25 will be 5. Okay. So when we take the square root we will get here 4 4s are 16 and 5 5s are 25. So when we taking square roots from both the sides, what we get? AB upon PQ is equal to 4 upon 5. Okay. And you can give the reason by taking square root from both the sides. Okay. So when you take the square root from both the sides you will get AB upon PQ is equal to 4 upon 5. So here you can write AB upon PQ we got 4 upon 5. Okay. Now see the next sum, the fourth sum. Triangle LMN is similar to triangle PQR. Okay, this is given. and what is given is 9 into, okay, 9 multiplied by area of triangle PQR is equal to 16 into area of triangle LMN. If QR is equal to 20, then find MN. Okay, so first what we will do is we will write whatever is given. Here what is given? Triangle LMN is similar to triangle PQR. So we will write it first. Triangle LMN is similar to triangle PQR. This is given. Okay, now see this next thing what is given is 9 into this whole thing, we will write it as it is. This thing you write it as it is. 9 into area of triangle PQR is equal to 16 into area of triangle LMN. Okay, write it as it is. Now what you do is, see, area of triangle PQR is equal to 16. Write this. Area of triangle PQR is equal to 16. Area of triangle PQR is equal to 16. This LMN is in multiplication, will come here down in division. Okay, you have to get it here in division. Area of triangle LMN. Okay, then this 9 is in multiplication, get it down here in division. So what you get is, see, keep this as it is. PQR is equal to 16. This is in multiplication, get it here in division. This 9 is in multiplication, get it here in division. Okay, now we can say by theorem of areas of similar triangles, we can take their corresponding sides. Like suppose area of triangle, we can say that area of triangle PQR upon area of triangle LMN is equal to, now the squares of their corresponding sides. Squares of their corresponding sides, which what is given here, QR and MN is given. So we are going to use these two sides, QR and MN. We are going to take the squares of these two sides. See here, QR is given 20 and MN is we have to find. So areas, ratio of the areas of two triangles is equal to the square of their corresponding sides. So the squares of the corresponding sides, we are going to take these two sides, QR square upon MN square. Okay, now area of triangle PQR upon area of triangle LMN is equal to QR square upon MN square. We can write there by theorem of areas of similar triangles. Okay, now see this, PQR and LMN is given. PQR upon LMN is equal to 16 upon 9. So in this place, PQR upon LMN, we will write here 16 upon 9 is equal to QR. QR is given 20 here. Okay, QR is given 20, and we have to put the square here, MN square. Okay, see this, PQR upon LMN is equal to 16 upon 19. So write 16 upon 19 in this place is equal to QR. QR is given 20 and find MN. MN is not given, what we have to find. So keep it as it is. Okay, now what you will do is we will cross multiply. When see here, both the sides we have square and these also are square numbers. 3 3s are 9, 4 4s are 16. So we will, what we will do, taking square roots from both the sides. We will take the square roots from both the sides. This square and this square will get cancelled here. See here, this square and this square will get cancelled. And on the left hand side, these are also square numbers. Okay, we can take the square root of this. 3 3s are 9 and 4 4s are 16. So by taking square roots from both the sides, instead of 16 we will write 4 and 9. 3 3s is 9. So write 3 over here. 20. Here we have taken the square roots from both the sides. Here we will get only 20 upon MN. Okay. Now we can cross multiply over here. That is 20 multiplied by 3 upon 4 is equal to MN. Okay. So now this can be cancelled. We can reduce this. 4 1s are 4. 4 5s are 20. So what we get here is MN is equal to 5 3s are 15. Also you can write here by taking square roots of both the sides. Okay, here this square and this square got cancelled. Here also we took the square root. Square root of 16 is 4, square root of 9 is 3. So you can write here by taking square root of both the sides. Okay, so understood how we got the fourth sum. Now see the fifth sum. Areas of two similar triangles are 225 square units and 81 centimeters. If a side of the similar triangle is 12 centimeters, that means one side is given 12 centimeters, find the corresponding sides of the bigger triangle. There are two triangles given, smaller and bigger. Okay, suppose if the area of the bigger triangle is 225, area of the smaller triangle is 81. Okay, bigger and smaller. Now they have given you the one side of the smaller triangle is 12 centimeters. We have to find the corresponding side of the bigger triangle. Now we don't know the triangle, so we will assume that let the areas of two similar triangles be A1 and A2. Okay, let areas of be A1 and A2. Okay, and their corresponding sides we will assume as S1 and S2. And okay, now since they have said that the two triangles are similar, so we will use the theorem of areas of similar triangles. So we take A1 upon A2 is equal to S1 upon S2. Okay, A1 upon A2 is equal to S1 upon S2. This is by the theorem of areas of similar triangles. By the theorem of areas of similar triangles. Okay, now we will put the values A1 upon A2. A1, suppose a bigger triangle, if you are taking A1, so A1 is 225. In place of A1 you write 225. The smaller triangle is 81. Okay, now see here, bigger triangle, the corresponding side of the bigger triangle we don't know, so we will write S1 as it is, and S2 is 12. If the side of the smaller triangle is 12, so here we will take S2 as 12. You have to put the squares here. Okay, because the areas of the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Okay, now see here, again over here we can take square root from both the sides. If we take square root from both the sides, this square and this square will get cancelled. Okay, and these are square numbers, like suppose 9 9s are 81, 15 15s are 225. So what we get here is, instead of 225, when we take the square root of both the sides, 225 we will write 15. Okay, square root of 225 15, and 81 is 9. 9 9s are 81. So we took square root from both the sides. Here also, this, when we take the square root from here also, this 2 and this 2 will get cancelled, the squares will get cancelled. So what we get is S1 upon 12 will be as it is. Now what you do is, after we got this by taking square root on both the sides. Okay, so you can write here by taking square roots of both the sides. Okay, so understood how we get this? By taking square root from both the sides, we get this 15 upon 9 is equal to S1 upon 12. Next step is same way, you cross multiply here. That is 15 multiplied by 12 upon 9 is equal to S1. 15 multiplied by 12 upon 9 is equal to S1. Now you can reduce this to the lowest form. Now suppose here, if I am taking 3 3s are 9, 3 5s are 15. Again I can reduce this, 3 1s are 3, 3 4s are 12. So we get therefore S1, 5 4s are 20. Okay, so what was asked here? Then find the corresponding side of the bigger triangle. The corresponding side of the bigger triangle is 20 centimeters. Okay, so we have finished the fifth sum. See the sixth sum. Triangle ABC and triangle DEF are equilateral triangles. Okay, these two triangles are said to be equilateral triangles. So since they are equilateral triangles, both will be similar. Okay, those two triangles are similar because they are equilateral triangles. Equilateral triangles are always similar. Okay, so first, and if area of triangle ABC, these two areas of triangle ABC and DEF is equal to 1:2. Area is given, the ratio of the areas of these two triangles is given 1:2. AB is given 4, find DE. Okay, so first what we will say that it's given here. Area of triangle, first we write solution. Area of triangle ABC and triangle DEF are equilateral triangles. We can say it is given. Okay, this is given. Now we know that equilateral triangles are always similar. Okay, so we can say that triangle ABC is similar to triangle DEF. Okay, ABC is similar to triangle DEF, and if they are similar, we can write that area of triangle ABC upon area of triangle DEF is equal to, we have to take the ratio of the squares of their corresponding sides. Now which two the corresponding sides we can take? AB and DE. What we have to find? DE. So we will take these two. AB, we will take these two. AB upon DE. AB square upon DE square. Okay, AB square upon DE square. You can write here, by theorem of areas of similar triangles. Okay, now ABC upon DEF, you can take ABC. Ratio of ABC is to DEF is 1:2. So ABC upon DEF you can take 1:2, means 1 upon 2 you can take. AB square, AB is given 4 here, so 4 square upon DE square. DE we don't know, right? DE square as it is. Okay, now what you do is, you can see here ABC upon DEF is 1:2 is equal to AB square is 4 and DE is equal to, we don't know, so write DE as it is. Okay, now what we will do is, you can take the square roots from both the sides as we have done in the previous sum, by taking the square root from both the sides. Okay, so the squares will get cancelled over here. So what is left? 1 upon 2 is equal to 4 upon DE. You can write here, by taking square root of both the sides. Okay, by taking square roots of both the sides. Now what we will do is, we will cross multiply this. So DE multiplied by 1, that is DE will be DE only, is equal to 4 multiplied by 2. Okay, so therefore DE is equal to 4 root 2. Okay, DE is equal to 4 multiplied by 2, 4. You get, okay, 4, so 4 you can remove it outside over here, 4 and root 2 over here, under root 2. So therefore DE is equal to 4 root 2. Now see the seventh sum. In figure 1.66, segment PQ is parallel to DE. Okay, PQ is parallel to, see this, PQ is parallel to DE, they have said, PQF is equal to area of triangle PQF. PQF, that means this triangle, the smaller triangle, is given 20 units. This is given 20 units. PF is equal to 2 times of DP. This PF is double. It is 2 times of DP. Understood? This is double of this DP. Then find quadrilateral DPQE. DPQE. We have to find DP. This part we have to find. So, how we will get this? See, if you take the bigger triangle, if you find the area of the bigger triangle, from that, if you subtract the area of the smaller triangle, you will get this area of this quadrilateral DPQE. Okay. So, see the activity. Area of triangle PQF is equal to 20 units. This is given here. See, PQF is given 20 units. PF is equal to 2 times of DP. This PF is 2 times of DP, means it is double. Okay. Now what they have said, let us assume DP is equal to X. DP is X. So PF is double. That means it will become, this will be 2X. Okay. If DP is X, PF will be 2X because it is double, they have said 2 times of DP. Now DF is equal to, now see the whole thing DF, this whole thing DF is equal to DP plus PF. DF is equal to DP plus PF. DP is given how much? X plus PF we got 2X. So X plus 2X is equal to 3X. Understood? X plus 2X is equal to 3X. Now see both the triangles. In triangle FDE, the smaller triangle, the bigger triangle FDE, and the smaller triangle FPQ, the bigger triangle and the smaller triangle we are going to refer. So in these two triangles, FDE is congruent to FPQ. FPQ, because they form corresponding angles. FDE, this one and this one. FDE is congruent to FPQ. Why? Corresponding angles. Again, now this side, FED, that means this angle FED is congruent to FQP. FED is congruent to FQP. Okay. Again, these are corresponding angles. Therefore, triangle FDE is similar to triangle FPQ by AA test of similarity. Okay. Now, see. So, therefore, now see here, after you prove that these two triangles, we got two angles over here. So therefore we can say that these two triangles FDE and FPQ are similar by AA test of similarity. Okay. Now see here, therefore area of triangle FDE is similar to triangle FPQ. So area of triangle FDE upon area of triangle FPQ, we will take the corresponding sides here, square of the corresponding sides. Okay, so which corresponding sides we are going to take? Now see here, 3x square. What is 3x square? 3x is DF. This whole thing DF is 3x, x plus 2x. So we will take here DF square, and 2x. What is 2x? PF square. Okay. So here we will take DF square. DF square is 3x, 2x plus x, and PF is 2x square. Okay. So you see here the squares will get cancelled here. So here you get 3x square and x square is common. So this you get when you square this. Okay, this is whole square. So x square gets cancelled. 3 square will be 3 3s are 9 and 2 2s are 4 you get over here. Understood? Now see the next step. Area of triangle FDE is equal to 9 upon 4. 9 upon 4 area of triangle FPQ. So same way, see here, 9 upon 4 into FPQ. FPQ was how much? FPQ. FPQ, it's given, it was given in the question. FPQ was 20 units. Okay. So here we will take 9 into area of triangle FPQ. FPQ is 20 units. Okay. So when we reduce this, 4 ones are 4, 4 5s are 20. So what you get here is 9 5s are 45 units. Okay. So now you got the area of the bigger triangle. The whole area of the bigger triangle is 45 units. So as I told you, area of the bigger triangle minus area of the smaller triangle, we will get the area of this quadrilateral, what they have told you. Now see here, therefore quadrilateral DPQE. Okay, the quadrilateral they had told us to find, DPQE is equal to FDE, area of triangle FDE. FDE is the bigger triangle. So what we got, area of the bigger triangle FDE, FDE we got 45 units. So right here 45 minus area of the smaller triangle FPQ 20 units, it was given. Okay, so here 45 units, FDE we got 45 units minus FPQ was given 20. So 45 minus 20 we get 25 units. Since it is area, we can write square units. Okay. So we have finished this practice set. This was the last practice set of this chapter, Similarity. If you find this video helpful, please do like, share and subscribe. Thank you.